In this quick start video, I will show you how to change the attributes in RoutCad. We have a part. It is a small snowman. Now, if we click the middle mouse button on an element of this part, we can see that the depth of cut is 0.4 centimeter. We would like to keep 0.4 centimeter as a depth of cut for all the inner element, and we would like to make the outer element 0.8 centimeter depth of cut. What we intend to do is to change the material that this snowman will be machined from to a thicker material, and we would like to only groove the inner element, and then we want to go through completely the material on the outside so that the snowman will disconnect from the support material. At the moment, we've chosen a plastic that is 0.3 millimeter, so that's why the depth of cut is 0.4 to go through, but we are going to change from a 0.3 centimeter plastic to a 0.6. To do that, we go to machine, we click on material selection, and we're going to change from 0.3 to 0.6. Now, in this example, we have a material that falls exactly in the existing material in those selection. If our material doesn't fall in that selection, we can just click other and then click on done, and that will be fine. But since our material is within those material that we have, we can just pick it up. So we click done, and now what we are going to do, we're going to change the attribute of this element. So we go to machine, we click on depth of cut custom, and we already have enter 0.8 centimeter, so that is fine. We click on continue. When we do that, nothing is actually changed in the drawing because the depth of cut and the drill diameter is a property of an element, and that property is also saved with the drawing. When we save the drawing and when we load it back, it's active again. So by changing the depth of cut over here, we don't actually change the depth of cut on the drawing. Only if we draw a new line, it will take the depth of cut, the new depth of cut that we have selected. But for the existing object, they are not changed automatically. We have to go and change the attribute. We're going to do just that. To do that, we go to draw, to edit, and we select attributes. We could also have done Control A, and we're going to click on the outer element to change the depth of cut from 0.4 centimeter to 0.8. So if we click the middle mouse button, we can see it's 0.4. If we click the left mouse button, it becomes 0.8. And we can just go around and change all the elements in this way. We could also do a window selection by clicking the window selection, and we could select, if we have many objects to select, we could just select with the window. We have to be careful not to select what is inside. And let's see if everything has been selected. This is 0.8, 0.8. We can see it's 0.8 depth of cut over here. 0.8, 0.8, 0.8, 0.8. And this one has not been changed, it's 0.4. The reason why is that when we did the window selection, the edge of the element wasn't within the window. But that's okay. We'll click over here to select segment selection, and we'll just click on it, and then it changed to 0.8. Now, if we click any of the outer element, is 0.8, and the inner element is 0.4. So everything is fine. It's going to machine the inner element by 0.8 and the outer element by the inner element by 0.4 and the inner element by 0.8. So if we click on our material, now our material will change it to 0.6 centimeter thick. So because we did 0.8, 0.8 is more than 0.6, it will disconnect from the support material, but the inner, once is 0.4, it will only make a groove of 0.4 deep. So we'll have a face, an eye, and middle button that will be grooved from the main material, and then the outside will disconnect. Now, everything is okay, except that the first route is wrong, because we're routing we're routing the outside before we route the inside. We should do it the other way around. We should route the inner element, and then once we're done, we route the outer element. Otherwise, if we do it this way, we're gonna this snowman will disconnect completely from the support material. There will be nothing holding it, and then we're gonna go and try routing the element. The spindle is simply gonna damage the part, and that's not gonna work. So to fix that, that's easy. We can do view. We can display route arrow just to show us what's going to happen. We can see the green is the first routed element. You can see it will route the first element, second, third, and go all around and do the routing completely. And then it will move from 8 to 9, 9 being over here. It will move over here and start running the inside. Then this is wrong. So we're going to fix that. To fix that, we're simply going to erase the route. We're not going to erase the part. We're only going to erase the routing information. We click on erase. We go to the menu erase, and when we click on route, and we can either erase using by selecting a segment one at a time. So see, we erase this one, so this becomes first, and we erase that one becomes first. We erase that one becomes first. If we have many objects to erase the route, we could just do a window selection by clicking over here and selecting all the objects we want to erase the route. So now there's no more routing information. It's only construction element. So we'll continue. Now we're going to define the routing again. So we're going to go to machine, and we're going to click on route semi-automatic, and then we click on OK, and then OK. Now we would like to do a segment selection, so we're going to click over here, and we're going to define the routing. We're going to be routing the inner element clockwise and the outer element counterclockwise. This is called upmilling, and for this type of material we get a better result with upmilling. So let's do it. Let's route the first element clockwise. So remember, this is a full circle, and the full circle goes from 0 to 360 degrees, and there's actually a end point over here. The circle actually begins right here. So if we click up, that means the routing will be counterclockwise. If we click just below, it will be a clockwise routing. So we want a clockwise routing, so we're going to click just below, and we can see, we're going to zoom slightly by doing Ctrl-Alt-W and select the window. We can see, first of all, we have this element become green, which means the first to be routed, and we can see how it's clockwise. The arrow always indicate the end of the routing, so basically the routing begins over here, goes all around, and finishes over there. Now we'll do the same thing for the next circle, and we can see now it's pink, so that means that it's no longer the first. And another thing, the arrow is also clockwise, so it starts over here and finishes over there. And we also have a dashed line, which means that the CNC will start over here, go around the circle, make a clockwise circle to machine this circle we just did. Then the cutting edge will move up in the air by the clearance value that we've defined, and it will move away from the material and then move to that location, and will go back in the material and then machine this over there. So we continue in that manner. So we keeps on doing that. Then now we're going to go and machine it like that. and it goes over here, does it, and now we're going to do this one. It does this circle and that circle. So it's not so bad. We've done all the inner element first, and we have a depth of cut of 0.4 centimeter for the inner element. So basically we're only going to create a groove of 0.4 centimeter deep, and remember our material is 0.6 centimeter thick, so that means we are not going to completely disconnect the inner element. It's only going to do a groove like that. Now that we've done that, we're going to do a counterclockwise milling. We're going to route in a counterclockwise way on the outer element. So the closest element, to save time, machining time, we should not start there. We can just start, because the cutting tool is over there at that time. So we'll just start over here. The quickest, the closest element to the last element is over here. So we'll just start over there. We move here, we route, and then we just continue in that way until the end. Okay, now if I go back to view, show route, I can see how my snowman looks like now. First of all, we routed the inner element first, so the material, there will be no problem, it will still be there, and then we just routed this button. And by the way, this little button is going to look just like that, because remember, the material is 0.6 centimeter thick, but we only went down by 0.4 centimeter, so there is still going to be material left underneath to hold that little button there. But that over here is 0.8, so it will cut it through completely. So if you focus on the gray, whatever is gray is what will be left. What you see in gray will be left, and those little buttons will still be left, because they will be held down by about, because if we go 0.4 centimeter deep, and then the material is 0.6 centimeter, there will be another 0.2 centimeter behind that will hold the rest, and then this button will be held, and then it will not fall, and then this will completely disconnect. Okay, one more thing we're gonna do, go to view, show route. I will display route. I will show something. You can see that in this over here, all the arrows are nice. You see the arrow goes here, and then, but over here you can see there's something funny in the arrows. So we're going to zoom this area to see why the arrows look a little bit funny over here. So we're going to do Ctrl-Alt-W, and we will zoom a lot this area, and we're going to zoom some more. Ctrl-Alt-W again, and then again Ctrl-Alt-W. Now we're zooming a lot. Ctrl-Alt-W, we're zooming thousands of times. And once more, Ctrl-Alt-W, and we begin to see something. Ctrl-Alt-W again. Now we can fairly clearly see it. What is actually happening is those two lines don't actually connect to each other. There's a very small gap in between these two routed lines. So when the CNC will come over here, it will get to that point, and then that point is not connected to that point. Normally what's going to happen, because the gap is so small, RoutCad will automatically introduce a small routed line between these two, which by default is at the depth of cut of the last object, so you won't see anything because it's so small. The cutting tool will come in here, route, and then it will also route from here to over there, and then continue. So you won't see any problem. If the gap was too big, the CNC would move out of the material and then up in the air, and then goes back in with the next location. And there in the config file you can define how big is the gap that you want to do the continuous routing. So no, but in this case, the gap is so small, and for the time being, the continuous routing in the config file is set to half the drill diameter. So as long as the gap is less than half the drill diameter, it will just introduce another element and continuously route it. But if for some specific job you want to reduce the tolerance of continuous routing to something less than half a drill diameter, you can open the config file and then change that. But in this case, there will be no problem. So you don't need to, so your drawing doesn't need to be perfect. Even if you have some small gaps like that, RoutCad is able to deal with that without any problems. The problem only occur when the gaps are too small, too big. Obviously, then you might not get the result that you want. But for small gaps, RoutCad is capable of introducing, closing those gaps by itself, and you won't even notice that there was something wrong with your drawing when you look at the final product. So we'll zoom out by doing Control Alt R, and we'll do Control Alt X to zoom twice and once more, and then we'll do View, Show Route.